So the aim of our project is to investigate the production of aerosol, so oil droplets going to the atmosphere from the sea surface, then get transported in what we call the marine boundary layer, and then finally the deposition of these particles in coastal region. So investigating this kind of phenomenon is very important for all the transport of pollutant. So these are information that are crucial for many restoration plans for the environment, especially in the Gulf of Mexico region, and also to control the air quality. And these are information important for many health aspects of the coastal region. So for instance, to control effects on respiratory problems like asthma, whose morbidity has increased a lot in the coastal region in Gulf of Mexico.
Here in this project, our initial effort will be mainly focusing on the aerosolized oil droplet, because that's directly related to what happened after a large-scale oil spill. But as Dr. Yongo has mentioned, so whatever we learned from this project and the method we developed, as you asked, can be applied to the general situation where you have a natural environment, you still have all those particles from the ocean that carries the bacteria and the virus that can be blown by the wind to the urban area and get breathed in by people. So that is in general a public concern for public health. So we have particular application for oil spill relating, but it can be also general.
So I will start first from the experimental capabilities that we have developed at the University of Texas at Dallas. So now we have what we call the mobile LiDAR station, which is a remote sensing station where we can deploy a particular instrument that is called scanning Doppler wind LiDAR. In practice, there is a laser that we can scan in the atmosphere, and shooting this laser in the atmosphere can get information about the wind speed, turbulence intensity, and also the distribution of these particles, so that we call in general aerosol, but can be pollutants. And we can correct this at very long distances, for instance, range up to 10 kilometers from the coast with very high spatial and temporal resolution, so we can keep track of evolution of the wind and the transport of this particle. So we start in November a deployment at the Galveston Island State Park. So our station is now there and is collecting 24 hours per day data about aerosol and wind. And of course, our goal is first to observe the physics and evolution of this aerosol. For instance, we see strong dependency on the characteristic of the atmosphere, height of the waves, frequency of the wave, relative direction between waves and the wind. And of course, we are really collecting state-of-the-art data set on this topic. And all this data then will be analyzed and leveraged to inform modelers like Dr. Di Young from University of Houston to develop new models that will predict this information in the future.
So our research can unveil the dynamics in the aerosol transport and suspension in the offshore marine atmospheric boundary layer. Mainly, it's wind blowing over a mobile surface because it's covered by waves. It's much more complicated than wind blowing over land. Our study can unveil the dynamics of the aerosol transport in this complex environment. And this is something important and unique in Gulf area because only here you have the mobile surface that's covered by wind-generated waves that can cause complex transport phenomena, and we have to have a good understanding so that we know how those aerosols would be first generated, then being transported by the wind towards the urban area, right? So if the wind is blowing onshore, it will carry those too.
Yeah, as we explained, so the experimental part, so with the LiDAR management and the modeling part, will help to produce a tool or a certain number of tools to facilitate this prediction of transport of pollutant from the ocean to the coastal region. And of course, we want to increase the quality in temporal resolution, spatial resolution, but also in the quantity of pollutant that will reach the coast after some spill events like what happened in the past. These information are crucial for many scientific and technological pursuits. For instance, for when we design restoration project for the environment in the coastal region. This information is extremely important because the transport of pollutant is extremely dependent on the local characteristics of the ocean and atmosphere. So bridging together, the experimental information and prediction will be extremely helpful for restoration project.